Hello boys and girls, and welcome to Mrs. Bandu's Math Movies. This is for Course 3, Lesson 3-1, Exploring Square Roots and Irrational Numbers. I had previously started this video and ran into some technical difficulties, so I already have some of this written out. Remember, I will probably unintentionally go too fast for you. Remember, you can always pause and so that you can catch up or stay caught up. Our objective in this lesson is to find and estimate square roots and to classify numbers as rational or irrational. Okay, I have a note of page 108 in your textbook. There is a diagram there and a paragraph that goes with that diagram, which are very helpful when you're trying to discern whether or not a number is rational or irrational. So I do not have room to write all of that here, but that would be an excellent reference point for you to go back and look at. So you want to be sure that you do that. Okay, we have a few definitions here. A perfect square. Perfect square is a number that is the square of a whole number. For example, 25 is a perfect square because 5 times 5 is 25. 16 is a perfect square because 4 times 4 is 16. A companion definition is the square root. The square root of a number is another number that when multiplied by itself is equal to the given number. So, for example, if I wanted to know what the square root of 64 is, that would be 8, because 8 times 8 is 64. It could also be negative 8. Negative 8 times negative 8 is also positive 64. Usually when we ask for just the square root, we're usually referring to the positive square root. There's sometimes indications that you want to name both square roots, the positive and the negative though. All right, our next term is irrational numbers. And they are numbers that cannot be written in the form a over b, or in fraction form, where a is any integer and b is any non-zero integer. Remember, b cannot be 0 because the definition of a fraction or a ratio is a divided by b, and division by 0 is undefined. And finally, the real numbers are the set of numbers including rational and irrational numbers. Rational numbers we studied in our previous chapter. They include fractions, integers, decimals, terminating and repeating decimals, I should say, and so on. The irrationals are what we're going to be looking at in this section particularly. They would be something like the square root of 2, because the square root of 2 is not a perfect square. Therefore, its square root is irrational. Also, the non-repeating, non-terminating decimals are classified as irrational numbers as well. For example, pi is probably the most famous non-repeating, non-terminating or irrational number. So, again, if you'll refer back to 108, those are a helpful little diagram there to kind of sort through these. Okay, in example number 1, we want to find the square root of perfect squares. So find the 2 square roots of each number. By saying 2 square roots, we're looking for both the negative and the positive square root. So we all know that 9 times 9 is 81. Negative 9 times negative 9 is 81. So the 2 square roots of 81 are 9 and negative 9. 1 over 36. 1/6 times 1/6 gives me 1/36. Negative 1/6 times negative 1/6 also gives me 1/36. So the 2 square roots of 1/36 are 1/6 and negative 1/6. Okay, sometimes also we'll just want to estimate the square root of a value, or so if we want to estimate the value of the opposite of the square root of 70 to the nearest integer. Since 70 is closer to 64 than it is to 81, the opposite of the square root of 70 is approximately the opposite of 8, or negative 8. If I look back here at this little scheme, negative 8 would be the opposite of the square root of 64. Negative 9 would be the opposite of the square root of 81. Okay, 70 would be a little bit closer to 64 than it would be to 81. So somewhere in this vicinity, if we estimated, it would be closer to negative 8 rather than to negative 9. All right, you have some quick check questions here, 4 of them, number 1 and number 2. One has various parts. At this point, remember, you may pause and do it now, or complete the video and then come back at the end at your discretion. Okay, here we have an application of squaring a number and also square rooting it as well. The math class drops a small ball from the top of a stairwell. The students measure the distance to the basement as 48 feet. Use the formula. Distance is equal to 16t squared, where d is the distance in feet and t is time in seconds, to find out how long it takes the ball to fall. Okay, so we will use the formula. D equals 16t squared. We'll substitute in 48 for distance because they measured that the distance to the bottom of the basement is 48, is equal to 16t squared. Remember, our goal is to isolate the variable, so we're going to divide each side by 16. Okay, and your book actually, they did it right here, but anyway, you need to show the division by 16. 48 divided by 16 is 3, and 16t squared divided by 16 is t squared. Okay, now find the positive square root of each side. Okay, so the square root of t squared is t. The square root of 3 is 1.7320, and it continues. Use a calculator for that because 3 is not a perfect square. So to the nearest tenth, it's 1.7. So it takes about 1.7 seconds for the ball to fall 48 feet. So again, you will need to be using a calculator on here. And remember, the square root of t squared is going to be t because t times t. Okay, t is repeated twice as a factor, so it's its own square. The square root of t squared is t, excuse me. Okay. And lastly, we want to classify real numbers. Identify each number as rational or irrational and explain. Okay, my first one is negative 9,333.3 repeating. This is a rational number because the decimal repeats. And if you'll remember back in chapter 2, we showed a way how we can turn that into a ratio. So since I can do that, I can go ahead and write this as a rational number. 4 and 7/9 is also rational because I can write it as the ratio 43:9. 4 times 9 is 36 plus 7 is 43. Letter C is the square root of 90. The square root of 90 is an irrational number because 90 is not a perfect square. There's nothing times itself that gives us 90. And finally, the last one, 6.3636663666. This is irrational as well because this decimal does not terminate, nor does it fit the definition of a repeating decimal. Although there is a pattern in here, it doesn't repeat in such a way that we could draw a bar over that repeating, over the digits that would repeat. Okay. Again, we may need to review our definition of a repeating decimal. You can look that up in Chapter 2. Also, be sure to ask about it in class if you need to. All right. Go ahead and finish the quick checks. Bring those in along with any questions you may have for discussion, and I look forward to seeing you in class. Thank you.